For part 3 of our training, we're going to take a look at the analyze step and go through the various different options that you have when running an analysis, including tolerance, as well as the different parameters that control how our algorithms interpret the data. We'll also talk about what impacts the duration of the analysis process so that you can get the best results in the minimum amount of time. Now, as you can see here, we're ready to click Analyze. We have brought all of the items and scans in from the second training video. They're ready to go. If your Analyze button is grayed out, it's probably because you haven't brought in either the scans or the items, so make sure that you have both. Once you do, and you click Analyze, if you have not saved Navisworks, or if it hasn't auto-saved, you will get this pop-up which is reminding you to save Navisworks. So again, Verity is a database. Everything you do in it is saved once it's completed. Navisworks is not. So if Navisworks crashes, if you had a Windows update during the processing, if Verity crashes, if any of those things happen, you won't be able to select on an item in Verity and have that item be selected in Navisworks. We won't be able to have that link anymore. Now, all the information in Verity will still be saved, but you will basically have to run a new analysis if you want to reestablish that link. So we highly recommend that you click Yes on this dialog. Once you do, the Analysis Parameters dialog will open up, and you can see the various different settings that are available for you to adjust. To start, we'll talk about tolerance. This can be set in inches, millimeters, feet, any of the different units that we support up here. Generally speaking, we recommend this be set somewhere between about 1/8 of an inch or 5 millimeters up to about 3 inches or 75 millimeters. If you're setting it below 5 millimeters, you're really talking about something that's kind of beyond the range of most terrestrial scanners to accurately measure within, unless you're using a sub-millimeter scanner. And if you're talking about the larger ranges, we would recommend you actually adjust the tolerance up after analysis for things that you want to treat with very loose tolerances for a pass or out of tolerance condition. This does impact how we pull the geometry to match up to the point clouds currently, so you really want to kind of top out around 3 inches for this initial setting. I'm going to go ahead and click OK and get this started, and then we'll talk about these other 4 options as it's processing. Let me pull up the user manual, which you can find in the Start menu under ClearEdge 3D. And this will give you some additional information that we won't really cover today if you want to dig into it further. But basically there are 4 settings that you can adjust. The bottom 3 are set by default. The top one's probably the most important. This is the one that is going to tell us how do we handle data that has gaps or holes in it. To clarify what I mean there, if you look at the HVAC ductwork and the Navisworks window here, you'll see there are a lot of gaps in the scan data, and you can see the duct model through it. That's because it had a shiny insulation wrap around the ductwork, and that means a lot of the sample points, instead of reflecting back to the scanner, actually reflected to another point in the project. So in cases like this, if you're outdoors and there's holes in the data, it typically means that it's because there's nothing there. That's the sky or mountains miles away. If you're dealing with indoor data, typically it means there's a material reflectance issue. So that's why we call this the indoor project option. And if you are in a scenario where, for the most part, you should not be seeing the sky or things too far away for the scanner to register, you're going to want to check this box. The next 2 options are really the different steps in our algorithm. So setting the classification will define whether or not something is installed, whether it's missing, whether we think it's occluded, etc. And then finding the as-built position is really where we pull the geometry to find the best fit within the points that are sampled around it. So if you want, you can uncheck either of those or both of them. That really turns off most of the algorithms if you do. There are some fringe scenarios where this is useful, but we can talk about those in a different video. The last one is the check and repair damage geometry. The short version here is that Navisworks is not very particular about how geometry comes into it. That's part of its strength, but it also means that frequently that geometry can have some unusual gaps and issues. So we have a step in our process that will fix those issues so that we get better results out of our algorithms. However, on items that have thousands or tens of thousands of triangles, that step can take a long time. So if you're dealing with very complex geometry, you're probably going to want to uncheck that box. Most of the time it's not an issue, which is why we have it checked by default. Analysis duration is really impacted by three factors. Geometry correction we already talked about and really only makes a significant difference for highly complex geometry. The largest impact is really the number of points that we have to pull from Navisworks. We have to go through the Navisworks COM API, and the easiest way to think about this is a very large drink with a very small straw. And it just takes a substantial amount of time to get all of the points out of Navisworks. If you look at the user guide, we have a comparison using the training data set that processes 3 different scan densities against the same 50 items that we're testing today. This will give you an idea of the different durations and the different results. There are slight differences in the results, but this primarily affects very small items, which the de-densification results in less than adequate points on the object, or items that are very close to the tolerance threshold and maybe flip back and forth with the addition or subtraction of some points that are being processed for the analysis. In that situation, you should be reviewing each of these issues and determining whether it's actually a problem that needs resolution or not, so it doesn't have a substantial impact on the final output of the analysis. For situations where you're wanting to test very small objects, then you may not want to be as aggressive with the de-densification as we were with the training data set. The last impact is the number of items that are being processed. This scales very linearly, and we can usually process each item in 1 to 5 seconds depending on the size of the object, complexity of its geometry, and the number of points on that object. So as you can see here in the background, Verity has finished processing the results. Took about 3 minutes and 19 seconds this time. Given us our high-level overview, 15 passing items, 26 out of tolerance, 5 were occluded, 2 uncertain, and 2 not found. So in the next video, we will go through the QA/QC process of validating these results and getting ready for the last one, which will be reporting.